Good morning, everyone. Welcome to INB371 Data Structures and Algorithms. My name is Maoning Tang. I'm working for the School of Electrical Engineering and Computer Science. And my office is in S Block on level 10. That's the room number, 1021. And there is my phone number. My email address is also there. And I don't have a regular weekly consultation. But if you need a consultation, please send an email to me. Then I think it's probably 24 hours before the consultation time. Then I can manage it to arrange a private consultation for you. There are other 3 teaching staff in this unit. They are all tutors and markers. So those are the people and their email address. And I believe they will introduce themselves to your guys in the first particle. Some today, some tomorrow, right? So I don't want to waste too much time talking about this. There are one prerequisite for this unit, which basically is object-oriented programming language. So any object-oriented programming language, for example, if already done Java, already done C#, that's perfectly fine. As long as you have already done one object-oriented programming language, should be fine with you. But some of you probably have not done any object-oriented programming language. Maybe have done one procedure programming language, like I say. For those, you definitely need to spend a little bit of time to catch up. Because as I will talk about in a few minutes, so basically, as the name implies, this subject is about data structures and algorithms. So it's not a programming unit. But we do spend a lot of time teaching C++, but focused on data structures and algorithms in C++. All right? So I want to talk about a little bit more about that in a few minutes' time. Those are the unit code and the unit title that we used in the past. So if you have already done one of these, probably you should not do this again because there are significant overlap. Right, so this is the prerequisites for this unit. So those are the learning outcomes. So by the time you successfully finish this unit, you should be able to, so for example, use abstraction and encapsulation technology. So there are a lot of, it's pretty wordy, so I don't want to go through, explain them one by one. So those learning outcomes, actually, you can find in the CUO, right? So if you want to look at the details, so you can dig out the CUO for this unit. So actually, this is copied and pasted from the CUO or course unit outline CUO. So basically, if you just look at the number 6, so number 6 basically is working independently or working in pairs, as you use a modern programming language to implement the programming solutions. The reason why I would like to emphasize this is because in this unit, which we are talking in a few minutes' time, we have 3 assessments. 2 of them are programming projects or assignments, something like that. So the first one will be done individually, and the second one will be in pair. So that's why. So I just want to emphasize this. So for the others, I think they are pretty straightforward. If you have not got time to look at it, I would suggest you take a look because these are already showing in the CUO or course unit outline, which you can find from Qt Virtual. The content covered by this unit, basically three components or three parts. Number one, C++. So again, we're not going to teach C++ from scratch. So when you come into this unit, I assume you guys are very comfortable with object-oriented concepts, right? But of course, in C++, for objects, for example, is a more complicated, is a slightly difficult than the objects in C# and Java. So my focus, when I talk about C++, number one, we focus on data structures and algorithms in the standard class library of C++. And of course, because we use C++ as the only program language as a vehicle to deliver some concept. So of course, I will talking about, very briefly talking about C++ as well. But my focus will focus on the difference rather than teaching C++ from scratch. Okay, hopefully you can get my idea. So we're not going to systematically because we don't have time, number one. Number two reason, the focus of this unit is about data structure and algorithms, not about C++. Having said that, we still spend quite a lot of time. As you can see, in the first few lectures, we spend a lot of time talking about C++, right? And the second part, of course, data structures. And the third part is algorithms. So basically, three components. So those are the contents to be covered in this unit. So every week, starting from this week, we have a 2-hour lecture, which is this. And also, we have a 2-hour practicals or workshop. Doesn't matter which you call. So sometimes we use the terms interchangeably. So sometimes called practicals, sometimes called workshop. But anyway, that's no difference. So I should emphasize the workshops or practicals start from today. So some of them allocate some to today's practicals, some for tomorrow's. Anyway, start from week 1. All right? So there is one practicals will start right after this lecture. So because some units start from week 2, right? Where this one will start from today, from week 1. Okay, we got 3 assessment items. The first one, you can see from there, will be a small size programming assignment. Basically, involve object-oriented program languages. Right? Of course, you probably need to use a little bit simple basic data structures. Right? That's for the first assignment. The first assignment needed to be done individually or by yourself, and will be released in week 3 and will be due in week 6. All right. So the second assignment will be a medium scale, medium size, also assignment in C++. And for the second assignment, you need to be got to be done in pairs, a group 2. All right. And that one will be, of course, needed to use what I put over there is ADTS or abstract data type, which I'll talking about in a minute. Basically, you need to demonstrate your knowledge and skills in data structure and algorithms, which is the core of this unit. First one, probably more about C++ programming. The second one is a major one. So we need to demonstrate data structure and algorithm knowledge and skills in the second assessment item. And of course, the third one will be a final exam, which is scheduled. We still don't know the exact time at this stage yet, but will be during the final exam period. Okay, so those are the weightings. First one 20%, second one 30%, and the last one is 50%. Okay, you don't have to pass each of the assessment to pass the unit. Right. So if you overall, if you got 50%, then you pass. Otherwise, fail. Right. So as easy as that. If you guys have any questions, please feel free to ask me at any point. Any questions so far? Okay. there is a new policy about later assignment submission. Actually, these are not new, actually introduced in the first semester of last year. So probably it's not new to your guys, most of you, if not all. So you just need to pay or need to pay attention to that. So basically is you need to submit your assignment before the deadline. So if after deadline, if you didn't submit your assignment and you didn't get your extension, so basically we will not mark your assignment at all. We are not marking assignment, and therefore you got 0 for the assessment item, and the grade is 1. So this is basically, I believe most of you have already know that. All right. And if you have some special situations, circumstances, then you should apply before the deadline. And also you can apply for special consideration, right? Depends. So if you have time, if you think you have the ability, the only matter is the time, then you can apply. And of course, you got some special circumstances, then you can apply for extension. But if sometimes, if you don't think you have some trouble finish the assignment, and even you give some extension, then you may consider to apply for a special consideration. All right, so there are some detailed info. So this, where you put application, you put here, and which are considered. So which situation you should apply for extension, in which situation you should apply for special consideration. So this is being explained here very clearly. So if you can click the link, so it will bring you to the faculty's website where you can get a very detailed information. So, for example, if you have already lodged application for extension and you have not got the response by the time the assignment is due, so I would suggest your guys still submit incomplete assignment. And also, when you submit assignment, you also submit your application, a copy of your extension application receipt. So we know, okay, you are applying for extension. Because now, unit coordinator, actually this extension application is handled centrally at the faculty level, not handled by the unit coordinator, not handled by me. So once your extension has been approved, the faculty student services will send me a notice to say who has granted our attention for how many days, under which grant, and so on and so forth. All right. Resources. This is the only textbook we have for this unit. And oh, by the way, did you know the publisher, Pearson? The publisher now has offered an electronic version of all the textbooks. For any textbook, they charge $50, so which is cheaper than the hard copy. Actually, I got the information last year from from a guy from Pearson. I'm not quite sure if it's still the case. Anyway, just to let you know, there is another option, because to buy a hard copy of textbook probably costs $100 or maybe more. But I just tell you, there could be another option over there, which is in the electronic version of the textbook. So I leave the, if you cannot find the information, let me know. I can talk to the Pearson representative to see if the option is still there. And also on the Blackboard, I put quite a few resources, like for example, a tutorial for C, tutorial for C++, and tutorial for example, for not a tutorial, the instructions for installing and running code blocks, which is the IDE that we use in this unit. All right. Oh, one thing I should mention to you guys is The only program language that we use in this unit is C++. Okay? And the compiler we use is GCC. All right? This is a compiler GCC, not a Microsoft one. It's a GCC. Right? So you can get your tutor will tell you more detailed information during the first particle. Right? And code blocks is a cross-platform IDE for GCC, which is a C++ compiler. It's an integrated development environment similar to Visual Studio. Right? Similar. It's very, if you have already used Visual Studio, it should be very easy to adapt to the new environment very quickly. All right. So I would encourage you guys to install GCC together with code blocks in your home computer, because for their assignments you need to use code blocks. Okay, you need to use a GCC and code blocks. Your tutor will give you a demo in the beginning of your first particle. They will give you how to open and how to close code blocks, how to install code blocks, how to use code blocks to edit a program, modify a program, build a C++ program, and run a program. And also it comes with debugger tools, which will be terribly useful when you develop medium and large size C++ programs. And of course, the unit, the course unit outline. This is something. This is the one item that I would suggest take a quick look very seriously if you have not done that after the lecture. Any question about the unit so far? No? Okay. Now, I give you guys an introduction to data structures and algorithms. So why data structures and algorithms are important? All right, so this is what I'm trying to talk about right now. So data structure algorithms are the two major aspects of software design. So when you develop a C++ program, for example, you may need to handle some structured data. So one issue you have to address is how would you save, how would you keep, how would you store the data, which may relate to each other in a computer system, in your program. Not just simply store the data, the structured data or data in your program. When you store the data, you consider the design of the data structure. You need to think about if you can easily access this data. And also, if you can process the data very efficiently. All right? Because those issues will directly affect the performance of your computer, of your program, of your software. All right? This is one issue. There's another issue is you have to deal with algorithms. So you basically design a program is a problem solving. So given our computational task, you need to design our computer software to solve that problem. So which means how to solve the problem. So you need to design an algorithm. So algorithm basically is a step-by-step instructions following which you can solve a computational problem. This is another one. Of course, for the same problem, different people may come up with different solutions. Maybe one solution is better than others. Then how would we know if we have two people, two developers develop two different solutions for the same problem? How would you judge which one, the quality of the solution, which one is better than others? Right? This is about algorithm analysis, which also be touched, not talked about in very detail in this unit. This is about algorithm design, algorithm analysis. All right? Just to give you guys a concrete example. So for example, I believe you guys use a GPS, maybe dedicated GPS for your car, or maybe GPS in your smartphone, right? So GPS. So for the GPS, you got some data. So for example, for GPS data, basically is the route network. So you need what's the name of the road, for example, what's the limitation for the road, the speed limitation for the road, and how the road are interconnected with each other, which road connected to which road. So you need to also not simply save all the information about all the road for Queensland, for Australia, somewhere. You also need to consider, how to, perceive the the relationship between the data, between the route, for example, right? This is about that structure. And also, a typical functionality of GPS is about navigation. So for example, you need to find what's the short distance from my current position, or maybe from one position to another position. In terms of time, could be in terms of distance. So these are the two typical options, right, for today's GPS. So this is about algorithm. You need to design an algorithm, right, a solution to the problem, an algorithm to find what is short distance between the two positions, for example. So this is a typical example. And of course, when you for example, use a particular program language to develop a solution, of course, you should consider how to make good use of, how to take advantage of the features provided by the program language. So in different program languages, maybe the data structures are implemented different ways. All right, so this is another issue. So this is why we also this is why we will need to spend some time talking about data structures and algorithms in C++ as well. That's why. So what's the features provided by them? How could we use those features, make good use of the features? If there is no existing data structure available, then how should we do that? So this is something that we covered in this unit. So you would have to develop a scratch, we call it ADTS abstract, which I'll talk about next, right? And then you use it, right? This is a reusable data type we'll talk about next. Okay, excuse me. So one important concept that I will use in the rest of lectures is we call ADT, or abstract data types. So what's meant by that? So abstract data basically is a specification of a collection of data items together with a set of operations defined on the data set, on the data. This we call an abstract data type. All right. So for example, when you use a program language like C#, so you use some predefined data types. Actually, they are abstract data types. For example, integer, right? So when you can use an integer. So integer basically, what are the data? What a set of data or integers? That's all the integers, right? That you can represent. And operations, for example, you can addition, subtraction, multiplication, and so on and so forth. Those are the operations. Those are the operations that define another data type, right? Of course, those are predefined data type. This type has already defined in the compiler in the standard C++ program language, so you can use that straight away. Then you probably got a question to ask me, so what's it mean when you say abstract? What's it mean by exactly by abstract? Because abstract, so for example, when you use integer type in C++ or in any program languages, did you worry about the implementations of those operations? For example, how the data are actually stored in your computer program? You wouldn't know, right? And how the, for example, operations like multiplication, addition, how those operations actually implemented? We didn't care when we use it, right? So if we needed to know the details of the implementation in order to use a data type, that would be terrible, right? So the key point is abstract. Abstract is in the sense that the implementation is separate, is separated from the specification. So we know there is a data type available, for example, in C++, integer data type available in C++. And we know what operations, for example, multiplication, addition is defined for data type. We can use a straight away. We don't need to worry about the underlying implementation. So this makes life much, much easier. And we don't need to know that, the implementation details. So the major concept is we separate what from how. So this is the key point behind abstract data type. So what means, what's the operation is defined on the data type or the abstract data type. All right, for example, addition, multiplication, So those are the, we only need to know what operations are available, which operation defined on that type. And how is about the implementation. How is, for example, how addition or multiplication operations are implemented. Right? This, we separated the concerns, separated responsibilities, right? So as a user of a data type or abstract data type, so we only care about, we're only interested in the, what operations are available defined data type, right? Because the implementation is the abstract data type provider. It's their responsibility to implement the data type. For example, C++ compiler developers, they provide, they actually implement the operations beforehand, before give to C++ compiler to you, right? So this is the separate what from how. This is what's meant by abstract data type. In C++ program language, we have a program construct, pretty good abstract, that can implement this. Some of you probably already use C++ or maybe C. So as you know, in C and C++, we have a headers file. Anybody heard of that? Headers file? No? Okay. Headers file, for those of you who have a background in C# or Java, it's something like an interface. They only specify the operations without any implementation details. So deep implementation actually put in another file. That's a CPP file or C++ program file. That's the implementation. So in the headers file, you can only see the interface, the prototypes. So you only tell you what operations are available. For example, multiplication, so on and so forth, something like that. But implementation is in a separate file. Okay, your tutor will tell you more about that. Maybe we can also talk about more in the following lectures. Anyway, this is a very important concept. You got to understand abstract data types or ADTS. Now, any questions about abstract data types? Okay. Now, I'm going to give a very brief introduction to C++. Anybody here has already done C++? Okay, quite a few, that's good. Or C as a procedure program language? Oh, quite a lot. Okay, good, thanks. So as you know, C was developed in Bell, the famous Bell laboratory in 1970s, right? C is a procedure program language. Anybody can tell me what's a procedure program language? We got quite a few C people. What's a procedure program language? All right. So, okay, procedure program basically, so if you use a procedure programming, our system developed in a procedure program language consists of a number of procedures. If we talk about the procedure in the context of C program language, the procedures are functions. So for those of you for the C++ programmers, for C programmers, so when you develop our solution or software using C, for the first thing in the design phase is you break it down in terms of functions, number of functions. Each of the functions basically implement is a solution to one small problem, one sub-problem or something like that. All right? But object-oriented programming language is different. Object programming language, basically, if you look at the solution, by object programming language, you can say a number of classes. So our system consists of a number of classes rather than a number of functions or procedures. So this is the difference. These are two different programming paradigms you got to understand. So this is the major difference. So if you have already done C, but have not done any program languages, object-oriented program languages, for those of you, you probably find it's pretty hard, because when you design our software system, you need to change your way of thinking. Because when you break it down, you have to break it down, right? So there's a strategy to handle the complexity. But when you break it down, not in terms of functions, but in terms of classes, all right? Okay, back to business. C is a procedure programming language, which is invented in 1970s. And C++ is a program language built on the top of C program language, all right? It was developed also in Bell Laboratory in 1980s. But C basically is a superset of, C++ is a superset of C. What's mean by this? What's mean by that? C++ is different from C# and Java, which are pure object-oriented programming language. C++ actually has two programming paradigms. C++ can be used as a procedure programming language, and also can be used as an object-oriented programming language. All right, so this is the major difference. So by the way, when C++ was developed, was invented in 1980s, there was no Java or C#. They are developed later, at a later time. All right, but in this unit, we use object-oriented C++, object-oriented C++, rather than use a procedure C++. Okay, so just to make it very clear. So in the solution, for example, when you do the assignment, you need to use object-oriented C++ rather than use procedure C++, which consists of a number of procedures. All right, so just to make this one need to be clear. So this is very simple. It's a hello world program, C++ program. Of course, actually, from this one, as you can see, there's no objects, there's no class whatsoever. So basically, this is you can see this is C++. You can also say this is a C program. There's no fundamental difference at all. But in this class, in this program, we do need use some objects, class and objects features. Okay, just a very simple program, hello world program. And probably very briefly, I don't think we can, talk about a typical program in very, very detail because of time limitation. But I can show you a typical C++ program. Okay, the top one. So this one. So in the program, in a C++ program, I now start with a sharp, or hash, indicate this is we call pre-processor directive. That's the instructions given to the compiler. So the major functionality of a compiler is translation. To translate a high program language in this context, it says C++ program language into machine language, which can be understood by the machine, because this is the only language that can be understood by a machine. It's a machine language, all right? So this is the instructions given to the compiler, all right? So for example, we have different ones. For this particular one, so it's hard to see here, that's indicate in my program, I probably use some standard or console input and output, which those functions, standard or console input and output, has to be already predefined in one class library. which is IO stream. IO stream is a standard C++ class library. So because I'm going to use it, so I need to include it. I need to include it so that my program can use it. So this is the instruction given to the compiler, okay? But that one, so this one, the pre-processor directive will not be translated into any program, into machine language. This is just an instruction given to the compiler, right? And I don't think you guys are new to this concept of namespace anymore because you also use a namespace in Java and also use it in C#, right? Basically, it's a way to resolve the name conflicts, right? So you know that, how to organize, so something like a folder, right? So if you, in your computer, in your C drive, computer C drive, for example, if you want you have two documents with the same name, you cannot put in the same directory or same folder. But it's perfectly fine if you put in two different subfolders or directories, right? So namespace is something like that. It's something like a folder, something like a directory. It's just a way of managing, to resolve the name conflicts. Anyway, you already know that. So all the C and the C++ programs start with this function. All the program has a function, main function here. And this is, this doesn't work very well. Always start from the main function, right? It doesn't matter it's a procedure, C++, or it's an object-oriented program. Always have a function, one and only one function called main. So this is the starting point of your program, right? So what's it mean by this program for those of you who are not familiar with C++? Cout basically is an object. For those of you, I assume you guys know object. What do you mean by object? What do you mean by class, all right? So cout is a predefined object of this class, or IO stream, which is a class, okay? So this, actually, I will talk about it in more detail. Basically, it's a represent output stream, which is associated with a standard output. Typically, it's a screen, all right? So this is an operator we call insertion operator, right? What I mean by this is we send this stream of characters to this output stream, which is associated to the standard output, which is the screen. So which means we display hello world onto the screen. We'll talk a little bit more about that. And this is just another object of this class, of our stream class, which means we change a line. We change it into a new line. Rather, otherwise, next time when you print out something, you start from the end of the string, hello world string, so we change a line. So that's pretty easy. And return, of course, the return to the calling statement. But this is the top level, so that's just stop, right? It's a very simple program. Oh. Now, I quickly talking about the data types, predefined data types, or fundamental data types that different people use different terminologies, or fundamental data, standard data type, or built-in data types, whatever, in C++ very briefly, because your guys should be very comfortable with this, right? So we have integral data types, so have floating data types, char types, Boolean data types, and there's a very important operator. This is not a function. It's an operator called a sizeof, which sometimes is, is terribly useful. So we'll talk about it very briefly. In terms of integral data types, so we can break it down into two subtypes. One is unsigned integers, another is, of course, signed integers. So unsigned integers, we can further break it down into three subtypes. So they are unsigned short, unsigned for unsigned int. We simply use unsigned. All right, actually it's unsigned int, and unsigned long. So all of them actually the data. So those are the, if we use the concept of abstract data type, so actually all the abstract data types. What are the data, for example? Just use the data, for example. The data are the non-negative whole numbers, for example, 0, 1, 2, 3, 4, 5, 6. The difference between the three types is only the maximum number or the range, the maximum number they can represent. Why? Because for unsigned short, we use 2 bytes, right? So each byte, each byte 8 bits, right? We use 16 bits to represent unsigned typically. Where when I say that probably is not very safe. Why? Because this is machine dependent, right? So in one machine could be longer, in another machine could be shorter. For example, we have 64-bit machine, we have 33-bit machine. So if you use a different machine, it could be different. The standard basically for unsigned 2 bytes or 16 bits, right? So, and also we define some operations. So these are the data, and also define some operations like addition, subtraction, and so on and so forth. There's one data type, So we define 3 unsigned integer data types. And of course, we have signed integers. They are short, int, and long. Again, the difference between the 3 is the range, the maximum number or the minimum number they can represent, how many numbers, the range they can represent. And for short, also 2 bytes. For int, typically 4, I can only say typically 4 bytes. And for long, 8 bytes, typically. But again, it's a machine, they are machine dependent. So just to draw your guys' attention, different machine. In the same program, if you run on different machine, you probably get different result. Okay, that's why. And the floating type, we also got 3. We have float, we have double, we have a long double. So typically for float, 4 bytes. And double, 8 bytes. Long double, we got 16 bytes. So again, difference, what's the difference? So they are represent real numbers. The difference, again, is the range. The number they can represent, this is the floating 3 floating data types. And also we have char type, basically for characters, right? Char type in C++, this is char type. We were talking about the string types, maybe sometime next week or the week after next week. In C++, we have 2 different strings. One is we call the C-style string. Another one is object-oriented. It's a class. It's an object string. We're talking about that later on. So, but again, so in order to understand C-style string, we need to understand character type. So this is the character type, right? So the char is a reserved word. Reserved word representing one data type. So you got the data, which is A, B, C, D, and blah blah, and the operations, for example, concatenation, and so on and so forth, right? So this. In C++, our char basically is represented regardless of the machines. Always use 1 byte, okay, to represent 1 char. So 1 byte represent 1 char. So this is different from bytecode, where we use 2 bytes to present 1 character. All right, this is different. Boolean type. For those of you who have only C program background, you don't have a Boolean value, right? So you only use 0 or 1 to represent true and false. But in C++, we do have a Boolean type. So we have a Boolean type of bool. So you can define, for example, a Boolean type of variable tested, and the value could be true or could be false. For example, for this situation, it's initialized as true, right? So this is a Boolean type. Boolean type actually also implemented in 1 byte in C++. Okay, This is an operator. Sizeof is an operator terribly useful, particularly in C programming language. Sometimes, for example, for those of you who already done C, you need to dynamically locate some memories. If you want to get some dynamic memories during the runtime, you need to tell the system the size of the memory you need. But you need to know what's the data type, right? So this is the one you can use to get the data type, right? So you know the data type, so you know how many bytes you want to get from the operating system during the runtime. Anyway, so this is the syntax. The sizeof is not a function, or again, it's not a function, it's an operator. It can take one operand, which either a data type or object or value. All right. There are some examples over here. So, for example, the first example is size of char, as you can see. The first example over there. So, char is a data type. That's perfectly fine. The value of the n would be 1, because we use 1 byte. This is return the number of bytes, right? So we use 1 byte to represent a char. So n's value would be 1. This is the first syntax. The second one, there could be also a value or object. Okay. When we say object in this context, the object not necessarily to be the object of class, right? So this is also considered as an object in C++. So this is a value, actually it's an expression. So we evaluate the value of expression first to say what's the type of the value. So for this one, for example, it's a float. That's if I assume A is a float type, then they would return n's value would be 4, because we use 4 bytes to represent one float data type. All right, it's pretty much the same, just a different variation. All right, so this is pretty easy. This is a very simple program that you can play if you want after the lecture. So you can download, you can actually copy the program and pass it into the IDE and then try and run the program. So this just gives, as you can see, we check a different type of the different built-in data types. We say what's the size of this data type on this particular machine. All right. Again, the outcome, the output from this program could be different if you are run on different machines. Okay. But some of them, for example, char always the same, always 1. But for other data type, hard to say. All right. So this could be different. Now, a very simple one, so quickly go through. Actually, it's quickly recap some concepts. So when you write any program or C program, C++ program, so you probably need to use some variables, or temporary variables, for example, or maybe a global variable, maybe a local variable. Anyway, you probably use some variables. So in C++, if you want to use a variable, you must declare it first, okay, before you can use it. Otherwise, the program, your C++ program, would not compile. Right, this is the one. So this is the syntax. It's pretty much the same with one other programming languages. For example, char is a data type. C is a variable of char type. Int is a data type. I and j are 2 variables of int data type, and so on and so forth. And also, you can put the initialization together with the declaration, like this. For example, char c equals to a. That's declare variable, and also get a variable of char type initialize. Yes. Say it again.
Can we do that in the same line?
Which one?
Like char c equals a.
Char c equals, the same line is fine, perfectly fine, yeah. And also you can separate, they are equivalent. For example, if you use first one you declare like this, char c, and in the second line you say c equals to a. That's equivalent to that. You can put them together, you can put them separately. Okay. Okay, now I quickly talk about the constants used in C++ before we take a 10 minutes break. there are three ways to use. Sometimes in a program, you wouldn't like to use or you have to use a constant in your program. So in C++, you got three ways to define, to declare, to use a constant. The first one is we use we call literals, like this. So for example, in this program, this is the first program, which as you can see, basically is used to calculate the area of a circle, right? So it's used to calculate the area of a circle. So where you need to use a constant 3.14159. So this is the one way to use it, all right? So I will introduce the three ways or three different type of constant. Then we're talking about what's the difference. Everybody asking our guys, what's the difference? So anyway, this is the first way to use constant in your program. We call it literal. The second one is called a typed constant, right? It's still the same program, the same program, but just use a different type of constant. So this, rather than using literals, we can use type. We call it typed constant. What's mean by typed constant? So this is the type. For example, here, so the top, we call it const. We use the reserved, the keyword const for constant, right? And followed by the type, which is a double, followed by identifier, something like a variable, right? So pi equals to 3.14159, right? So pi will be our constant, which means you cannot you cannot change the value in the program once it is defined, right? So this is the constant. This we call the typed constant. And the last one is called pre-processor definition. So this is a pre-processor definition. Did you remember the line start with sharp hash, hash define. So this is another way. So pi here in the third program also a constant here, used here. Okay. Then I got a question. I'll probably challenge you guys because some of you already done C. What's the difference between those two, between the typed constant and the pre-processor definition constant? What's the difference between the two? The same functionality, there's no problem. What's the tiny difference? What's the difference between the two constants? Anybody have a? Sorry. Yeah.
Isn't the amount of space you need to store the value if it's redefined?
So if we use typed constant, where the constant value is stored? Sorry? Second?
8 bits. It gets 8 bits per bubble.
Right.
Yeah, but define it gets another memory allocation, so it doesn't make a difference.
Right. Actually, the major difference is, for those of you who know the detail of the compilation process, if we use the first one, type the constant, for basically any variable. Actually, even this is not a variable, it's a constant. When you load the program into the main memory, the computer system gave a piece of memory, which for this type the double is 8 bytes to this one, pi. So pi is associated with a particular memory in the main memory, right? Associated with the location of the memory. And this value is actually stored over there. So whenever you use a pi, for example, now I want to calculate, I use r times pi. Whenever you want to pi the value, you need to create a reference to that address in the main memory where you can get the value, right? So every time you use a pi, you need to visit that location where pi's value is stored. This is the situation after compilation. So, well, this one is different. Pre-processor definition is different. Pre-processor definition is, let's say, here we only have one occurrence of pi. In a program, you could have multiple occurrence of pi, right? So here we use a pi, maybe another program also use a pi, which is a constant. But if we go with the third option, which is a pre-processor definition, during the combination, during the pre-process of combination, all the occurrence of pi will be replaced by by this literal 3.1415. All right, all the places will be replaced, which means probably. So when you access, so next time, for example, we do the calculation, R times 3.159. So you don't. There's no separate memory where the constant is stored. You directly use the value. So which means this is a little bit more quicker. You don't need to visit another place to get the value before you can calculate the value, right? Before you can evaluate the value of the expression, you can directly use it. It's more efficient, right? So it's hard to say it's good or bad. Anyway, some people prefer this, some people prefer. Of course, this also got its problem too. For example, after you compile, you translate the C++ program into a machine code. For example, you want to do, use a debugger to do the combination. You would not able to find our constant. You would not find pi. All you can find is 3.14159. You cannot. There's no pi whatsoever. Wherefore, the top option, the second option, type the constant. Yes, you can see there's a pi over there. And you know where it's stored, what the value is. That's some very tiny difference. Anyway, not a huge difference. Okay, any questions before take a 10 minutes break? Okay, let's take a 10 minutes break. Okay. Now we look at assignment statement in C++, which doesn't make any difference at all with the assignment in C# and Java. But anyway, so this is the syntax. We're quickly looking through. So you're basically on the left-hand side, you have a variable, and the right-hand side of the assignment operator, which is equal, what's called assignment operator, is an expression, right? So for example, in C++, it's perfectly fine if you use this. You can declare multiple variables of integer type in the same line, and you can get some of them, for example, B and C initialized, but not the other two, not A and D. So these are good assignment statement. And those actually all are good assignment statement. And those are not because the right-hand side is not a single variable, right? So that's pretty simple. Okay, now we're talking about console or standard input and output in C++. In C++, we use the concept, we use the idea of streams. So we're talking about what's meant by streams. Actually, this is the same idea that we used in Java and C#, right? So basically, a stream is in some textbook is defined a flow of bits. Some of them is defined a flow of bytes, because bytes is this minimal meaningful unit. Basically, that's why they use bytes. Anyway, doesn't make a difference. So for input and output in C++, actually is performed with stream, the idea of stream. So if the flow of bytes are flowing into a program, that's what we call our input stream. So if you have a flow of bytes or flow of bits flow out of your program, we call output stream. All right. So if we want, for example, if we get the input from the keyboard, which is a standard input device, so the input stream flow from your keyboard into your program. If we want to display something onto the screen, so a flow of bytes is flow out of your program to the screen. So this is the idea, right? Of course, not just the standard, not a console, just the standard input and output. You can use the same idea for file input and output, maybe network drive input and output. Anyway, now we only, at this stage, we only focus on console stage input and output. Okay, console input. So for console input, we use an object. So at this stage, it's very hard for me or impossible for me to explain to you in very detail how it works. Because in order to understand what's happening behind the scenes, what's happening, you need to understand, for example, IOStream class, how the IOStream class is defined, all right? And also, you need to very comfortable with the operator overloading concept, which I'm not sure anybody know operator overloading? Very few, probably. Okay, so you need to understand that. Otherwise, it's very hard for me to explain why is that. So once you know the idea, then it's very easy for you to understand. So we don't need to worry about what's behind the scenes at this stage. So as long as you can use C in and C out for input and output, which is pretty simple, then that's fine, no problem. All right. So if we use C in or use in console input and output, so you definitely need to include IOStream class library, because C in, C out again are two objects which are predefined in IOStream class. All right. So that's why you need to include, to make sure you include. There are different namespaces, and most of the standard or common use class libraries are defined in STD namespace. So that's why we use a namespace. Otherwise, you would have to use specified namespace. For example, when you use C in and C out, rather than directly use C in or C out, you would have to use STD followed by resolution operator, semicolon, semicolon, and followed by C in. You would have to use this. All right. So if you want to use output, you need to use a C out, right? So two operators. One, this we call insertion operator, all right, which is used for C out, used for output. There is an extraction operator, which is that one at the bottom. This one. This is used to extract data or value from the standard input, which typically is the keyboard. All right. Two operators. So those two operators actually are, for those of you who know what I mean by operator overloading, those two operators are overloaded in IOStream class. This is why you can use in that way. So anyway. So this is a very simple program demonstrating how to use C in and C out for standard or console input and output. Very easy to understand. So you can use it straight away after this lecture. So in the beginning of the program, so we declare two variables of integer type. They are x and y. All right. And then we output this string. We output this probe onto the screen to enter two whole numbers. So these enter two whole numbers will display onto your screen. Okay. So the user got this probe. Say, I put two whole numbers. For example, 3 and 5, just an example. And then you can use a C in to get the input, to extract the value from the string input stream, and put the first value into x, which is 3, and put the second value, which is 5, into the second variable, which is y. Okay, assuming the input, the user enter 3 and 5 from the keyboard. All right. So and then use C out again to display display what? Display first x, so you print x, which is a 3 onto the screen, and then followed by this one plus, followed by y, which is 8 onto the screen. 3 plus 8 equals to the value, the evaluated value of this expression, which is 8 for this instance. 3 plus 5 equals 8 onto the screen, and then you change your line and stop. Right? So it's as easy as that. Very simple. Any questions about console input and output, which you will use a lot in the practical, in today's practical, and or maybe today and tomorrow's practical. Okay, very easy. Without, for example, if you say, if I remove user namespace std, would the program compile or not? The answer is no, because we're confuse the compiler. So if you remove user namespace std, you would have to put here, you would have to, for example, before cout, you would have to put std. I draw down onto the whiteboard for you guys. You would have to use std, this we call the resolution operator, 2 semicolon. You would have to use this, the same with std cin. Right. But if because you have already specified the namespace, which is std, you don't have to use std resolution operator followed by cin or cout. Okay, now very quickly recap the control statement used in C++. There's no dramatic difference. Use the same control statement you in C, in Java, and in C#. All right, so there's no difference. We'll simply quickly recap. These are the fundamentals of C++, which you need to use in today's practical and tomorrow's practical, of course. So those are the control statements that I will talk about next, very quickly, of course. So there are two types of if statement, which is if the conditions are true, and then we do something, which is a statement. The statement could be a single statement, could be a compound statement, a number of statements starting with a curly bracket and finishing with a curly bracket. This we call the compound statement. And the second one, the second type of if statement is this one. If the condition is true, this statement 1, which again could be a single, could be a compound statement. Otherwise, or else would do statement 2, which could be single, could be a compound statement. All right, so very easy. This is just an example demonstrating how to use those two types of if statement very quickly. I don't think anybody should have any trouble at all understanding this. Just an example, right? So this, the function of the program, as you can see from the top comments, is to find the minimum of the three integers. So you ask the user to put 3 integers, and the output the minimum one of the 3. Okay. So first of all, we use 3 variables, x, y, and z, and the mean, which keep the minimum we got so far, right? So initially, we ask the user use a cout. Please input 3 integers, and the user put 3 from the keyboard. You extract the input of the user from the keyboard and put them into 3 variables, x, y, and z in that order. And first of all, you compare x and y to see which one is smaller. And you put the smaller into mean, which is also an int variable. And then you further compare the third one, which is stored in z, with the minimum one of the 2 of x and y to see if this one is even smaller than that, right? If it's smaller, then we update. Otherwise, no. Then we output the minimum one is, which is stored in mean, using cout. So pretty easy, right? This is the if statement. And there's a 3 loop statement in C++, as in most of program languages like Java and C#. The first one is a while statement. Excuse me. The syntax basically will have keyword while, followed by expression, which give the value or Boolean value should be Boolean value. But in C++, if the value is an integer, it's also fine. But anyway, I don't want to confuse you guys. It's good practice to use a Boolean value. All right, but in C++, this is not a problem for those guys who have any background in C, because 0, 1 actually represent 0, true or false. They use in C++. This is perfectly fine, but this is not good practice. All right, in C++, it's not good practice because we already got a Boolean type. In C, we don't have a Boolean type. So event value, basically, if the condition is true, we keep doing until the condition becomes false, until the expressed value becomes false. So this is a while. This is an example, very quickly. So this is an example. The function of the program is to find the maximum of n real, this time not integer, but real numbers, right? So first of all, we ask the user to put the maximum value, just to show the functionality, also what the program will do, and then how many numbers you wish to enter. So for example, the user enter 10. Then this program will check if the input is valid or not. For example, if a user input a negative number, this program would ask the user to re-input again until the input is a positive number. And then they should please enter 10 real numbers if the enter was 10. And then here, we do them one by one. Initially, we get the first one, and the maximum one we call so far, of course, is the first one, which is stored in the variable x. And then, okay, this is the key point. We use a while loop. Okay, we use a while loop. When this condition is true, then we keep doing. So this is, as you can see, this is a compound statement, which consists of 3 basic statements. This we call the compound statement, right? So if the second one is bigger than the maximum one got so far, we update the maximum. We update the max. If it's smaller, then we just ignore. And we'll get the next one, read the next one, and compare the next one with the maximum one got so far. If it's bigger than the maximum one, we need to update max, the maximum one, maximum. Otherwise, we keep going again until we repeat how many times, because assuming the input was 10, because we already got the first one outside before the while loop. So this will be repeated for 9 times, and then we output the maximum value. Oh, by the way, are you guys comfortable with this? Anybody can tell me what's this? Yes or no? Do you want me to explain this? Yes, okay. This is basically just a variable, right? CNT. This is equivalent to this. But of course, there are some differences. Probably it's dangerous to say they are equivalent. No. So basically, it's an incremental operator. So every time you do this, increment, so the value will be increased by 1. So this basically is increase the variable's value by 1 every time you do this. All right. There are 2 types of incremental operators. Right. There is one. That one is called pre-incremental. So we put this one. We put this one, the plus sign, plus before the variable name. There's another one called post-incrementer, which basically is also equivalent to this, increase the value by 1. But there is some difference. What's the difference between the 2? The difference between the 2 is, for this one, we increment its value first before use its value. Okay, the first time we had this probably a bit confusing, but I'll give you an example. This is called a pre-incremental operator, so which means you need to change the value. You need to increase the value by 1 first before you can use that value. Well, this just different, just the other way around. You use the value first and then increase. Okay? So this is the difference. So for that one, for that particular example, here, so initially, as you can see, initially, if you look at the top, initially the variable and initial value is 0, cont value is a counter, is 0, right? So the first time, when we, in the first iteration of the while loop, the bottom while loop, so we increase the value first, was 0, then we increase the value by 1, now it becomes 1. Okay, then we use the value. Now, we say if 1 less than n, which is 10, then condition is true. Then we keep doing. All right? If we change this one into this format, post-incremental, that would be different. Then, for example, still the same program, then in the first iteration, we would check, currently we have not changed the value if we use this one. If we replace this one with the pre-incremental with the post-incremental, then we compare the value, we use the value first. Current value is 0. 0 less than n, yes. And then after check the condition, the Boolean, the expression value, and then we increase cont, the counter, increase by 1. So the value that we used for comparison was 1. Oh, sorry, was 0 rather than 1. Where if we use this one, the value we used was 1. Did you realize the difference? So change the value first for pre-incremental. Change the value first, and then use the value for the comparison. And this one different. We use the value for comparison first, and then change the value. So this is the difference. Okay. Actually, now I got our. Actually, I have a program. Have a question and have to challenge your guys in a few minutes time. Anyway, this is the one. Now, any questions about while loop? Okay. So for loop, this is another loop. So basically, if you know the number of iterations beforehand, typically you should use a for loop, right? So this is the syntax of a for loop. There's no difference at all with the for loop in most of the other programming languages. The first expression, basically, as you know, is used to, because for for loop, you need to use a loop variable or loop control variable, right? So the first expression used for the control variable or loop variable initialization. And the second one basically is a condition to say if condition true, can you keep doing? Condition becomes false, we stop. Okay, we jump out of the for loop. And the third expression basically used to update the value of the control variable. All right, so that is an example here. Oh, this is a little bit complicated here. So for this one, so I can see basically the function of this program is to use to output all the triples of the integer that add up to n. So for example, if n's value, initially they're asking the user to give a value for n. So that's actually not asking the user, actually this is predefined. We use a constant at the top, which is a 7. So the function of the program basically is to output the triples of the integers, the triple of the integers that add up to 7. For example, 1, 1, 5, 7, 1, 2, 4, 7, and so on and so forth. So you need to enumerate all the combinations of the integers which add up to 7. Right? So this is what's basically what the program does. So in order to do that, we use a nested loop. We have three for loops, right? One nested inside of another. Right, so basically we change 3 variables I, j, and k to say if they add up equals to n, which is a 7 or not. If it is, we output I, j, and k onto the screen. Right? Otherwise, we ignore, we check the next combination. So in this way, we can check all the combinations and output all the combinations of 3 integers that can add up to 7. Right, so this is the functionality of the program. So this is a typical example for loop. Anyway, I got to be quick, otherwise I can't finish. Do while loop, there's another while loop. The only difference is the syntax. For loop, we need to check the condition first. If the condition is true, we don't do the loop in the loop body at all, right? Then stop straight away. Where do while loop is different. So the statement in the loop needed to be executed at least once, right? So we do them once first, and we check the condition is true. Condition is true, we do the second time, that's a loop body. And the condition is still true, we do the third time until the condition becomes false, right? So there's a difference between while and do while, okay? Do while, the body of the loop will be executed at least once. Or while loop probably does not do it at all. Okay, this is an example. This is just the print hello followed by the value of integers. But this time we use another operator we call a decremental operator. So similarly, for decremental operator, we have a pre-decremental operator and we have a post-decremental operator. The one that I use in the program I is post-decremental operator, which means we use the value first and decrease the value by 1. Okay. So the first iteration of the loop would be hello followed by, we use the value first, which currently is 10. So hello 10. Next iteration, hello 9, and so on and so forth, until the condition becomes false. So the last iteration, when so we print when I equals to 1, hello 1, and then we decrease the value, now becomes 0. Because I equals to 0, I greater than 0, the condition is not true, it will stop. So the output from this program would be hello 10, and the second line, hello 9, hello 8, until hello 1. So that's the output from the program. All right. Okay. I'm not sure if we got enough time to do that. Okay. Maybe give you, rather than 2 minutes, probably give your guys 1 minute to work out that program. So just the practice, The only thing, this is similar to the previous program, right? The only thing that I changed is I replaced the post-decremental operator into a pre-decremental operator. So maybe, what's the output would it be? Anybody can? From 9 to 0, right? So hello 9, hello 8, hello 0, and then stop, right? Are you happy with that? Okay, yes, actually that's the output, thanks. Okay, and then we talk about another 2 control statements. One is called a break. So sometimes we use a break a lot. So break statement can be used in while, can be used in for, do while, and also switch statement, right? This is not new to your guys. It should not be new to your guys at all. Your guys should be very comfortable with. This is just quickly recap, okay, what we have not, because you are going to use this in the first particle. That's it. Well, the second lecture, next week, we are talking some new to most of your guys. For example, we are talking about pointers, we are talking about arrays, particularly dynamic arrays. So there's some new content. But this week, pretty much recap, that's the content that you have already got, you have already know. Okay, what's the output from this program? So break basically means when you run break statement, which is a control statement, then you jump out of the structure. Okay, depends where you put the break. So if it's a while, jump into the while and then do the following statement. If it's a do while, the same. If it's a break, also jump. If it's a switch statement, also jump out of the switch statement and execute the next statement following the switch statement. All right. So for this one is this output from the program would be so for when x equals so starting from 1, right? So the if in the for loop, so the condition is not true, that we don't execute the break statement, right? We don't do break. Then we output x, which is 1, and put a white space, and next iteration we print a 2, and next we print a 3 onto the screen, and print a 4, and then when x value equals to 5, if condition becomes true. If condition becomes true, then we break, then we jump out of the for statement, and we do the control transfer to the statement which follows the for statement. So that is a cout, change a line. So the output from this program would be 1 on the same line, 2, white space 3, and white space 4, and then change a line. That's it. That's the output from the program. Okay, that's a control statement. Okay, there's another one similar to the previous program, but just add an outer for loop. Okay, so what's the output of this program? You only got 1 minute time. Anybody can tell me what's it? Okay. Sorry. So actually pretty simple, it's not that tricky. So actually output would be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 3 times. That's it. Okay, it's not that tricky. Okay, let's move to the next one. Switch statement. So switch statement, you got expression. This is the syntax. You evaluate the value of the expression and to see the result match up with which case. For example, constant 1, constant 2, constant n, or default 1. Okay, depending on which one can be matched. This is an example. So this is still a very simple example. So we have integer variable. Oh, by the way, there's another tricky place in C, which probably is different from Java and C#, but I don't think I have time to explain it in enough detail, which is in some, the char type actually can be treated as an integer type. They can use them interchangeably. Okay, I probably give this one as a sort of homework to your guys. You just do. Sometimes we use them interchangeably. Okay, so this is a difference between C++ and the other object-oriented programming languages. So as you can see over there, the type of grid is not a char type, but it's an integer type. That's perfectly fine with C++. All right. Then we say which case match up. So the third one, which is a C, right? Then we do this. We output OK onto the screen and then break. When break, jump out of the switch statement. Then we stop. So the only output is OK. It's this one. It's OK. Output OK onto the screen. All right. Now I have another question to challenge you guys. Again, this is not new. This is something that you should know. Now I just changed the program a little bit. What I did was I simply deleted 2 break statement. It's dying. This one because simply delete the 2 break statement. So my question is, what's the output of the program would be? Anybody can tell me?
Okay, and then you must look at it.
Exactly. So some of you in my previous experience may I'm not aware of that. So actually after that they were not check the condition again. They don't match up. They don't care. They were keep doing until they get encountered break statement. So the output would be OK, and you must do better, and then get a break, then jump out of the switch statement. All right. So thanks. Okay, continue is different. So continue break is jump off of the structure. Continue is to escape the remaining statement in the loop in the body. Just an example, because of time limitations, I'll quickly go through. So for example, for this one, so we have a continue. So the structure of the program is similar to the previous one. The only difference is when x equals to 5, rather than break, we continue. So my question is, what's the output of the program would be? So when x equals to 1, we'll print 1 onto the screen. When next iteration, when x equals to 2, we'll print a 2 onto the screen, and then 3, and then 4. When x equals to 5, we just jump to the end of the for loop, which is here, and back to the beginning. So as a result, we just skip the rest of the rest, which is the two statements. We just jump to here, ignore or skip the rest statement in the body. So as a result, 5 will not be printed out. And the next time, when x to 6, the condition not true, we print a 6, we print a 7, print 8 to 10, right? So the output of this program would be starting from 1, 1, 2, 3, 4, 6, 7, 8, 9, and 10. So this output on the screen, right? Okay, very quickly, there is one last topic, which is about the function. You guys are probably very familiar with this one, right? So basically, our C++, our procedure C++ program consists of a number of functions, and one and only one function is the main function. This is your starting point, right? So the program started from the first statement in the main function, right? So this is the one. For the function, just the syntax very quickly. I'm going to use a probably couple minutes time to finish up because this is not new to our guys. This is a syntax. So basically, you have a return type for the function, followed by function name, followed by a list of parameters. All right. So this is an example. So the function of this example is to print out, for example, have a nice day. How many times, given by the parameter value. So if the case value, when you make a call, you pass a value to k. If the value is 3, this program, this function would be output have a last day 3 times, right? This is as easy as that. For the function, so I think there is another one. Just look at this one. So in C++, this is slightly different. This is why I want to spend 1 minute time to talk about it. Right. So this function is a little bit more complicated than the Hello World program, because here, actually, this is a typical procedural C++ program. Why? Because we have not used any classes or objects at all. So this consists of 2 functions. One of them has to be a main function, of course, and this is starting point. And this function, main function, will make a call to another function which is called print messages, which is this, which you saw previously, right? You have already saw that. So I'm not going to look at the logic or the function in detail. What I'm trying to say is, basically, for example, for main function, if you want to make a call to another function, that function should be defined before main function. So if you copy, so basically you need to move this one to here, somewhere here, before the main function. That's perfectly fine. But some people say, I always want to start my program from main, and then put other subprogram or sub-functions after main function. If you want to do this, you have to put what we call it's a function prototype before main function. That's indicate now I will provide a function which call this. The return type is a void, and take this parameter, and this will be defined after main function. So without this one, the program do not compile. Okay. So if we want to put the function, other function is after main function, you have to put what we call a function prototype, which you can pretty much the same with this one before the main function. All right. And also 2 terms are used in this in the rest of lecture. One is we call the parameters. When I say parameter, I mean we use it in the prototype and use the definition. Parameters, when I make a call to the function, argument. I make a call to the function. I pass this one, this argument. So this is the term I will use in the rest of the lecture. Yes?
Do the parameters have to be constant when declared?
No. Answer is no. Thanks for asking me this question. Otherwise, I forgot to explain. Const. Const, so sometimes we have a const, sometimes we don't have a const. If, for example, for this instance, we specify this parameter is a const. What we mean by this is, for example, in the definition of the function, if you trying to change the value of k, which is a parameter, for example, somewhere in this function you say assign 3 to k, your program will not compile. Why? Because we have already indicated this parameter is a constant, which means you cannot change it. All right? Thanks for asking me. Know that. And void means does not return any value. Okay? This is what we call void. Any quick questions? Okay, then if no questions, thank you very much. I'll see you next week. Don't forget, there's a particle today.